Okay, so how is everyone today? Good, I hope. All right, so today's the 2nd. As a reminder of last time, we talked about the sign chart method. So we're going to do some more of that today. Good. So in this remark, I'm going to take the time to explain under what circumstance do we use the sign chart method. Okay. So as a reminder, or really, we haven't said it directly. We've said all the things necessary, but we haven't said this directly. So an expression is called linear linear. Well, let me just try that again. Linear when its plot is a line. So in particular, every expression of the form mx plus b is going to be linear. Because the plot of y equal mx plus b is a line. So strictly speaking, as a mathematician, I have to say, well, that's not entirely correct. Because, you know, mathematicians are like the lawyers of the science world. Strictly speaking, the real word here is affine. And, you know, some affine things are linear. But for our purposes, this is good enough. More or less, what you need to succeed in college algebra is the connection that, okay, such a thing is called linear when you plot it and what you witness is a line. Okay, so would you please remind me, what's the shape of absolute value? A V. So is absolute value linear? It's not, right? It's you know, it's not shaped like a line. So because absolute value plot is you know, like this, a V, that kind of thing. Absolute value is not linear, and so you call that nonlinear. Well, another example of a named shape that we know is parabola, right? So is a parabola a line? It isn't. Parabolas are not lines. And therefore, quadratics are not linear. Okay, so now I need to bring us back to item 1. So last time we were talking about the sign chart method. That's what we were using. And the question that we need to address is the following: is that 5. When you're given a nonlinear inequality, so you're given an inequality which is nonlinear, and you want to solve it.
Inequality means it has a directional sign, not an equal sign?
Right, instead of a nonlinear equation. So given a nonlinear inequality, on Wednesday of last week, we talked about nonlinear inequalities. We didn't call them that, but we'll start calling them that now. We dealt with absolute value inequalities, and we went through the 4 possibilities, where you had a V and a horizontal line, and there were 4 combinations. So if it is the absolute value kind, that is to say, for example, the kind that looks like this, 2 times x minus 3 less than 8. So, it's nonlinear, but it's this special kind. Then we have special methods. To solve such things. So that's from Wednesday of last week. That's where we said things like, for example, this one we would say between the eighths. So given a nonlinear inequality, if it's the absolute value kind, then we have special techniques to go about solving that. Otherwise, you must use a sign chart. And to be clear, maybe to the point of going too far, if you were given something like if you were given to solve, say, 13 x plus 14 less than 0, is this linear or nonlinear? It's linear. Well, that's the kind you just do your normal stuff, right? So this is linear. You just solve it the easy way. Without a sign chart. So now, strictly speaking, if you solved this one with a sign chart successfully, then you could have full credit for such an effort. I'm just saying that it's not necessary. Okay.
I'm almost embarrassed to ask this. Would you do it real quick?
With a sign chart?
No, with just the easy way.
Well, you move the 14 over,
Okay.
and then divide by 13. The reason why Well, let's consider. For inequalities, do we have a method to add, is it permissible to get the 14 over?
Yes, it is.
Yeah, you
Adding to both sides, right?
right. So adding or subtracting the same number to both sides always preserves the logical value. Then the next thing we would want to do is we'd want to divide by 13. Is it possible to divide by 13 in such a way that the logical value is preserved? It is. As a result, we could do that. Even if that were negative 13, is it possible to divide both sides by negative 13 in such a way that the logical value is preserved? Yeah. You just go ahead and do it, but you must also remember to switch the direction of the inequality. For anything that's of the form mx plus b, you can always get the b on the other side, and you can always divide by m. As a result, that's like the easy mode, if you take my
I think
meaning.
there's so many times that nowadays we've been splitting and having multiple responses
Mm-hmm.
that I'm just kind of stressed making sure that this isn't one of those, and the easy way is really easy.
So, to be clear, well, okay, let me say it like this. You know, when we're doing this stuff in class, you know, I write all these. You know, I just write so much. Just I get a cramp half the time, you know, writing. But I'll make an admission to you, and that is that in my head, when I think about these problems, it's not like that. When I think about these problems, it's like I see pictures in my head. I'm forming a hypothesis that maybe you're the same. What's the shape of this? A V, and that's a horizontal line. Just that one. So this one visually would look like this: a V. This would be y's absolute value of 2x minus 3. And then we'd have this, y is 8. Then the question is how many, do you observe that there's two intersections? That is the reason for the splitting. Now, if you were to plot, not to make things, I don't like it when instructors edit, but I'm going to do it, otherwise it's unclear. I'm going to change that from a 0 to an 8. Now, if you were to plot this, just this part, what would it look like? A line. It'd be a line with slope 13. It would look like this. And if you were to plot y equal 8, how would it look? A horizontal line. And, well, how many times do these touch? Once. The reason why something like this is going to split is because of two touches. The reason why this one will not split is because there's one touch. Now, the further we get, you know, we're going to start, we'll make the red thing be all kind of wiggly, like, and then there could be lots of them. And then we'll get to a place where the red one and the green one are wiggly. And then now there's all kinds of interesting stuff. But I just want to make it clear that it's not like some arbitrary rule. And when I think about it in my head, this is what I see. I'm not saying you need to see that. Other questions? Okay. So here's an exercise. Please find the natural domain of the square root of x squared minus 12x plus 20. All right. So, in which set is this exercise occurring? The reals, right? Because the standing order is that all exercises are in the reals unless explicitly stated to be in the complex. Good. So that square root is real square root, not complex square root. What are the two ways in which a restriction on the natural domain can arise in our class? Division by zero and? Very good. Negative inputs to an even real radical. Because negative inputs are permissible to complex radicals of any stripe. So notably in this exercise, there's no divisions whatsoever. So in particular, there's no division by zero, so that's good. So that means that that we don't even need to consider that. But we need to avoid negative inputs to the radical. So that means well, we're putting the thing inside the radical. So what's the name for the math name for a thing that you put in the other thing? Argument, right? So we want the argument to be what? Greater than or equal to 0. Therefore, we need to solve argument greater than or equal to 0. All right. So evidently, we need to solve this inequality. Well, now the considerations on the previous page come about. So is this the easy kind? What's the name for the easy kind? Linear, right? So is it linear? It's not linear. So we can't. This is not one of the easy kind. The next level of difficulty is it one of those special absolute value kinds? It's not. So it's this is not linear. So which is not linear. And it is also not the special absolute value kind. As a result, the rules of the game state that what must we do? We have to make a sign chart. Therefore, we're going to solve x squared minus 12x plus 20 greater or equal to 0 with a sign chart. I'd like to point out what work has been produced on the page so far. It's explaining the reason why we're doing what we're doing, and that's important for you to write down if you want to get full credit. But I want to. Well, I'll just observe that the things that have been written down so far are not things that students typically reckon to be work, because there's no algebraic steps, if you like. There's no adding and subtracting and what have you. But nevertheless, this is the explanation of what we're going to do and why we're going to do it. Okay, in the end, to find the natural domain of this expression, we've come to the conclusion that, oh, well, it's the argument that needs to be greater or equal to 0. That's an inequality, which is nonlinear, and therefore we have to use a sign chart.
Because it's greater than or equal to, couldn't you just make it an use the equal sign and make it, forgot the other term, a regular problem.
A regular problem?
Yeah, you just said it just a second ago. But, and then just say everything above 0, or above the answer, you know what I mean?
I'm not sure.
Okay, let me ask it again. So, because it's greater than or equal to,
Uh-huh.
hypothetically, could you just set it equal to 0 using an equal sign
Mm-hmm.
instead of the greater than or equal sign? Making it x squared minus 12x plus 20 is equal to 0. Solve that problem.
Well, in fact, so there's two answers to your question. Well, in the end, it is necessary to use a sign chart. But as we go through the sign chart method, we will in fact solve that equation. So it's going to happen, for sure. So the answer is no and yes. We are going to solve that, I agree, and no, that won't be enough unless it's in the sign chart. Okay, so good. So sign chart method on this inequality. So what is the first step in the sign chart method? Natural domain. Okay, now there is potential for confusion here. The exercise that we started a few minutes ago was that. The exercise is find the natural domain of this expression that I wrote down. Okay, that in the end, that's what we're trying to do. Then we established that, okay, in fact, we need to solve a nonlinear inequality. When you're solving a nonlinear inequality, the first thing that you establish is the natural domain of that inequality. So there's natural domain that was written in the statement of the exercise. You can think of that's the thing that I wrote. And then there's the thing that you wrote. As a response to your request to find the natural domain of that expression, I'm going to start out by finding the natural domain of this inequality. Don't falsely connect them. They're not identical. Okay, so what's the natural domain of this inequality? All reals. You're telling me that this inequality is true for every real?
No. Set. Could be.
Is defined for every real, right? So, because, ignore this stuff up here, we're just looking at this. 0 is fine. It doesn't offer any restrictions whatsoever. But for this, the only thing that could restrict the natural domain is divisions by 0 and radicals. And in this inequality, how many divisions by 0? None. How many radicals? None. Therefore, there's no restrictions. Okay. In the sign chart method, what is the second step?
0.
Very good. So we'll 0 and simplify. One of the steps is pretty easy. What step? Yeah, and it's already zeroed. Because remember, the 0 step is that when you're solving a nonlinear inequality, usually both sides have terms on them. The zeroing step is to move all of the terms to the same side, leaving 0 on the other side. But 0's already over there, so that's great. Okay, and then in this step, specifically, what kind of simplification are we after? Factoring. Now we're going to simplify by factoring. Well, does that factor? Oh, good. Okay, so will someone tell me how it factors? I didn't ask. I agree. Now, suppose that I hadn't jumped the gun and started writing it down, and I had asked, would it have been correct for y'all to respond x minus 10 and x minus 2? Yeah, that'd have been correct, because product commutes. But I'll let you know right now that that would be correct. And if you had said x minus 10 multiplied by x minus 2, I still would have written down x minus 2 multiplied by x minus 10. And that's not because I like to be difficult or, you know, try and twist your words or whatever. There's a reason that I would do that, and in fact, I've been doing it all semester. The reason is because eventually we're going to convert this to an equation. It's coming very soon. Then we're going to want to solve that equation. What are the solutions? What will be the solutions to that equation?
2 and 10.
2 and 10. After we have the solutions to those equations, we're going to plot them on a number line. 2 and 10. Which one is furthest to the left?
2.
And which one is furthest to the right? 10. So when I factor things, I endeavor to write the factorization, to make the factorization, the order, agree with the left to right order on the number line. The reason is because I find that some of the times when students are plotting these things, whenever they make errors in the left to right order of the things that they plot, the error, it is almost always the case that the erroneous order is the same order that these were in. So if student wrote like this, 2 and then 10, I'd give it I'd be willing to bet good money that they plotted in the right order. But if they wrote it the other way around, it'd still be correct, but now I'd have to change my bet that they might plot them in the wrong order. So I'm bringing this out now so that it's something that you can see and think about. All right, good. What's the next step?
Solve the equation.
Yes? So in particular, we're going to convert the answer to part 2, to item 2, to an equation and solve. Okay. Well, that'd be x minus 2 multiplied by x minus 10. And now instead of inequality 0, it'll be equal 0. Does this have a solution? Yes. The solutions are 2 and 10. All right. What is the fourth step in the sign chart method? Sign chart, right? The method is named after this step. All right, so that means we're going to plot the reals, and we're going to make some fence posts. What do we have to plot? 2 and 10, and where do we get those from? Yeah, from right there, right? Now, does that mean that in all exercises, all fence posts come from step 3? No. Right. In a different exercise, if there had been exclusions found in step 1, those too must be plotted. So what I want you to remember is that we're going to plot some fence posts now. So I'll go ahead and plot them. I'm going to plot 2 and 10. And in this particular exercise, both of those came from step 3. In a previous exercise, one of them came from step 1, and one of them came from step 2. What I want you to understand is that you could give me any two natural numbers, say 13 and 14. You can say, oh, I want you to make an exercise where 13 fence posts would come from step 1 and 14 fence posts would come from step 3. I could do it. It would be totally unreasonable, right? 27 fence posts? That'd be outrageous. But it could happen. Okay, so now that we've done this, now what? So we took the reals, and all the previous work, all the work up to here was to take the reals and make these two cuts. Cut, cut. Mm-hmm. Plug these ones? Okay, so I think you're saying choose a point. Okay, so something that's in here is like 1. Something in here is, I don't know, 7. Anything would do, right? I'm just choosing 7. And how about, I don't know, 13 for this one? That'd be great. So now we take these 3 selections and we plug them into the non-zero side of the zeroed and simplified inequality. But we're not actually interested in the value. Rather, we're just interested in the sign. So there's 2 factors here. When you plug in 1, the left factor is negative, and the right factor is negative. So in the middle we refer to this as the sine pattern. So in the middle region was the sine pattern. I can't agree. Positive and negative. Positive and negative because that one, well, if you do the arithmetic, that one would be 5 and that one would be negative 3. And then in the rightmost region, positive and positive. Okay, so that's the pattern in each region, but in fact we're only interested in the overall sign. So what's the overall sign in the left region? Good. The overall sign in the middle, negative. The overall sign in the right, positive. Okay. Because the product of 2 negatives is positive, the product of positive and negative is negative, and the product of positive and positive is positive. Any questions about the chart? Now we are in a position to make a conclusion. So, what the chart has done is we took all of the reals, we cut it into pieces, we labeled each piece with the label either positive, received a positive label, or the label negative, received negative label. The answer to the question is that we want all of one kind. We either want all of the negative regions or we want all of the positive regions. And on different exercises, it can be different. On this specific exercise, which label do we want? The positive ones. Why? Because we're just positive people? It's because it's a Monday, or? Right. So we want the positive regions. The reason why we want the positive regions is because when you look at the inequality, that's what it's saying. We want to know when that pattern is positive. It's totally possible to make a different exercise where that's turned around the other way. All right? So are there any positive regions? Yes? Well, the last thing to consider to make sure that you get the answer correct is that we know we want everything between negative infinity to 2. But the last thing that we haven't completely considered is whether or not what? Whether or not we want 2 itself. You know, maybe we want 2, maybe we don't. So you need to make a, I'll just write this down just as to remind you that we talked about it out loud. Do we want 2 or do we not? Okay, so whatever your response is, please tell me why.
When you plug in the value, it goes -8.
So we want it, right? We want it because, okay, have a look. In the end, the answer to the question is the inequality true at 2? And the answer is yes. Well, so in the first place, is it defined? Yeah, because we carefully said, yeah, it's defined everywhere. Then, if you plug 2 into that factor is 0. And I agree that that other factor is -8, but I also would submit that that's not even relevant because that one is 0. So yes, we want 2. Do we want 10? Yes, for same reasons. As a result, we could write the answer down in interval notation as -∞ to 2 square bracket. And then how do I complete this sentence? Union, right? 10 to infinity. And on such exercises, I'll ask for it. Please give it to me in all 3 ways. So how about as a plot? How do you draw it as a plot? Very similar. Okay. So this way takes a little less writing than the other style of plot that we've given. So one way is you could draw it like this. The other way is you could draw an entire number line and then, make it clear what part is included and what part isn't. Finally, we want to write this in algebraic notation. So, you can see that there's 2 pieces visually. That's why you have to have a union. It can't be simplified because there's 2 separate pieces. Algebraically, similarly, you have to give a description of each piece. So the piece on the left could be written as x less or equal to. How could the piece on the right be written?
X is greater than or equal to 10.
Very good.
What's the word between them? Is it or?
Because the connection in your head that I want to establish is that union is or, and intersection is and. Okay, wow. So that's the answer to the question. Okay, so again, we said this on Friday, but I'll say it again. In fact, I have news to report, actually. I went ahead and bought that T-shirt I've been meaning to buy, but it hasn't arrived in the mail yet. But it should arrive this week, and I'm gonna wear it first chance I get. The T-shirt I'm talking about it's a plain black T-shirt, and then on it says, "Yet another day has gone by, and I haven't used any algebra. Algebra wasn't necessary." And it's funny. Okay, even I think it's funny. It's funny because it's true. It wouldn't be funny if it wasn't true, right? Okay. What I mean is true in like a statistical sense. Like there's a great many, even for me, there's days where I didn't even do any arithmetic or algebra of any kind. Okay, fine. However, if you take that point of view too seriously, then you can sort of look at a question like this and say, wow, that's a lot of structure, right? Do I really have to do that? And the answer is, yeah. Yeah, if you want to get credit for an exercise like this, you have to do it. The reason in the end is that, all majors that graduate from UTD have to take algebra. You either have to have credit for it either because you took it somewhere else or you took it here. But even if your major and your intended profession essentially uses no algebra, and you can just fill in the blank of whatever stereotype major you have for that. Even if that is the case, getting an A in algebra is a signal to those who would read your transcript that, oh, this student has passed through the gauntlet of being required to write down a very structured and clear argument because they couldn't have got an A in algebra otherwise. So what's being graded here is that you're doing this. All of this mechanism and you're carrying it all out and turning all the cranks. That's what's being graded. I mean, in the end, this is like the summary. That's great, but this is what's being graded. Now, that being said, now I'm going to do another page, which I think was your point before we started the sign chart method. A comment on the previous exercise. So consider. So this is kind of like a remark, I guess. Consider x squared minus 12x plus 20, which is the quadratic from the previous page. So linear or nonlinear? Nonlinear. In fact, if you plot y is x squared minus 12x plus 20, if you were to plot it, then you would see a shape that is so common and so important that it has a name. What's its name? Parabola. So this is a parabola. In particular, one of the ways we classified parabolas is those that open down and those that open up. This particular kind of parabola, which variety is this one? It's the kind that opens up. So it's this kind because, well, you tell me. How can we tell that it must open up? Coefficient, right? Because the leading coefficient is positive, is 1, which is positive. I'll write it like that. Furthermore, with just a little bit of algebra, you can factor that. How does it factor? Well, like this, right? Now, sort of thinking this like a machine that you can provide inputs to, what kind of x input would you need to provide so that the y output would be 0? 2 or 10, right? Because if you plugged in x is 2, that factor would be 0, and it makes no difference what the other one is. Y would be 0. And if you plugged in x is 10, that factor would be 0, and it makes no difference what the other one is. As a result, if we were to plot this, what's the name of those 2 points that we were just talking about? Those kinds of points are so important that they have their own name. Y-intercepts? Other one. X-intercepts, right? Because I was asking where y is 0, and y is 0 on the x-axis. So this has x-intercepts. One of them is at 2, 0, and the other at 10, 0. And as a result, with these 2 pieces of information, we can give a somewhat passing sketch, a reasonable sketch of what must be occurring. So I'm going to draw, this is a plane, but I'm only going to draw the x-axis. The y-axis is over here somewhere. I'm not going to bother drawing it. 2 points that we know of are the intercepts. So one of the points that's got to be on the parabola is, I'll say, that one, and the other one is this one. So we know it's got to go through those 2 points. Furthermore, we know that it's got to open up. So it can't be that kind, which means somehow we've got to put a parabola through there. Now, another fact about parabolas that you could have that we lightly discussed when we plotted y is x squared, we said, oh look, when you look at the table of values, it reads the same forward and backward. What's that called? A palindrome, right? Like Taco Cat. So that visually manifests itself as a symmetry. So like humans have bilateral symmetry, more or less. Parabolas have bilateral symmetry. Because we have 2 points at the same height, that means that, in fact, where must the lowest point in the parabola be? Right in the middle of them. So that's enough to give you a really pretty reasonable sketch for what's going to happen. That's what it has to look like, more or less. All right. So again, the y-axis is over here, but I'm not drawing it because it kind of would confuse the matter. So, all right. Now, what I want you to observe is that these x-intercepts kind of split the whole plane into 3 regions. There's the region that is to the left of the first x-intercept. There is the region that is between, left and right between, the 2 intercepts. So the stuff that's over here, the stuff that's in between them, and the stuff that's on the right. So for these red points, remember the red points are points, so they have x, y values. What's true about the x values of these red points?
Less than 0?
I understand what you mean, but my question was, what about the x values?
They're between 2 and 10.
They're between 2 and 10. And then now the question that I think you thought I meant was, what about the y values? They're all less than 0. So observe that, that all of this is below the x-axis. And as a result, the y values are negative. All of these red points. How about all these red points? Are they below or above? They're all above. And therefore, what's true about all the y values? They're all positive. What about in the left region?
No, Dr. McCary.
Yes?
Everything you do has a reason. So there has to be a reason that you wrote the above x-axis y values as positive below the y-axis. I mean below the x-axis.
Well, what I want to say is the red points in this region.
Oh, okay.
Are above the x-axis. And similarly, how about in the left region? Same as the right region. So the red points are above the x-axis. And as a result, for those red points, the y value is positive. Now, okay, if it wasn't obvious, I hope I'll connect the 2 dots here and say, do you observe that's exactly the sign chart from the previous exercise? It's not a coincidence, okay? So, therefore, to solve x squared minus 12x plus 20 greater than or equal to 0, if one way to solve it, a separate way, if the exercise didn't explicitly say you've got to use a sign chart, one way to solve this you could plot. And report. Well, in particular, what I mean is you have to plot that quadratic. Y is x squared minus 12x plus 20, and report where it's above the x-axis. Interesting. So what I want you to, the purpose of this remark is to bring it to your attention that there's an entirely separate way to consider the question of a nonlinear inequality. And we're going to do both of them as just a very rough approximation of what it is that the sign chart method is sort of the logical conclusion of I'm going to use algebra to the exclusion of pictures. Right? I'm going to do it without pictures. And then this way is sort of like I'm going to use pictures to such an extent that I want to avoid algebra. And I'm going to give you exercises where it's one way or the other. Like you're going to have to do it this way, and you're going to have to do it the other way. Okay, so have a nice Monday.